Hi everybody, and thank you for watching this video. My name is Ivo and I'm a solutions architect and computer science educator. This is episode 3 of a video series presenting a proof of concept to connect and monitor a smart factory using a Matter controller. In the first episode, I provided an end-to-end overview of the proof of concept that I built, starting with how the new Matter standard can help with the interoperability in a fictitious smart factory. Then I walked through the proof of concept architecture and showed you a demo. In the second episode, we deep dived into the AWS IoT Greengrass based edge solution. In episode 1, we learned about the overall architecture of the proof of concept, and we saw a demo of the Matter controller controlling Matter enabled devices using the Matter protocol and the features of the AWS IoT core. In the second episode, we looked at the architecture of the edge solution, and we examined both the standard AWS and custom Greengrass components, and we learned about how the system offered offline and reboot resilience using the disk booter Greengrass component. In this third and last episode, we will dive into the CI/CD processes and procedures for streamlining DevOps and field deployment of the overall solution. So let's look at the architecture that we'll use to achieve this. Well, the continuous integration and continuous deployment starts from the GitHub repository. So from the GitHub repository, when we push updates to the repo, that will kick off some GitHub actions. Two main actions will happen. The first thing, we will use a GitHub action to go and build a multi-architecture Docker container and push that Docker container to Docker Hub. This Docker container will be used for the React-based admin server that we'll see later on. Also, we will have a GitHub action that will kick off the AWS CDK, the Cloud Development Kit, and this is our infrastructure as code. And this GitHub action will go and ensure that we set up the infrastructure. This will result in AWS CloudFormation stacks being deployed. The first CloudFormation stack to be deployed is the Thing installer. So the Thing installer will go and provision the Thing core devices and core groups. It will set up the relevant policy and will set up a set of temporary security credentials. Now, the first time we deploy the IoT Greengrass device, we will need to set it up using an install script. So we will have an install script that will use these temporary security credentials in a config file, and this install script will install the Greengrass component onto the Greengrass device and look after all the dependencies that are required for that. But it will also go and set up a secure IoT certificate, which will enable for a secure connection to be made between the IoT device and the AWS cloud. This only needs to happen once, and the first time that we go and create a Greengrass device, and then every deployment after that, this is not needed, only the first time. So in subsequent deployments, the next thing that will happen is that the code for our Matter controller will be uploaded into a S3 bucket. Then we will have a CloudFormation stack which will run a component deployment, and this will go and deploy the code to the Greengrass device. And the main component that we have is the Matter Cloud Controller, which is a Python-based custom component that will be deployed using the deployment to the Greengrass device. We will also go and deploy the API gateway deployment, which will deploy an Amazon API gateway, and this will interface with the AWS core in order to send and receive MQTT messages to the Matter controller. And the Matter controller then will publish messages back, and a IoT rule, a thing event rule, will go and pick some changes up that happen to our Matter devices, and we'll use the SNS service to send HTTP notifications back out to our React server. So any changes that happen on our Greengrass devices will be picked up by the Thing monitor, and they'll be sent back as HTTP notifications. In order for us to interface with the Matter devices, we will run several containers on the Greengrass device, and these containers will both host the Python Matter server and also the React server. And the React server will be used for locally managing the Greengrass device. But if you look deep inside what's in the React server, so the React front end uses a typical web and API type architecture framework using React. And what we have is we have a database which will be populated with all of the Matter attributes and endpoints. And the endpoints then will be accessible via an API, and that API then will go and be queried from the front end. And so this particular Docker container that runs on the Greengrass IoT device, this is the Docker container that has been initially built in the first step of the GitHub actions that we mentioned at the very start of this process. It's also important to note that every time we reboot the Greengrass device, we will look for the latest version of those Docker containers. So if we do update our Docker container or we update our React front end, that React front end will be deployed and we rebuilt as a new Docker container, the latest version. And anytime we reboot the Greengrass device, we'll take in the latest React front end server. And we're going to demonstrate this now as we look at developing a new change to our React server, and we'll see how that populates through all the way through to changes to the Greengrass device. So let's jump in. So let's look at the GitHub actions that launched the AWS CDK. So you can see here we have a GitHub action here, and what happens here is this creates a runner which goes and launches the CDK. So a number of things are happening here. We have to install the AWS CDK, we have to set up some configuration, and then we package up all the components here, and then we use the CDK deploy. And CDK deploy, what it does is it synthesizes the CloudFormation stacks and then it deploys those stacks. So you can see here we have a number of stacks here that have been synthesized and deployed as well. And what this results in, it results in the stacks being provisioned on the AWS cloud using CloudFormation. So we jump over to AWS and just have a look at the CloudFormation section here. We can see the stacks that have been set up by this GitHub action. And these stacks relate to these ones here. I've highlighted them here. So these stacks that we talked about in the video. So looking at how do we create a new Matter device endpoint. So we've got the, this is the local cloud controller running on our Matter controller. This is the React server running there. And this is the code for the React server. So this code, it's all run on what's called a Redwood app. So a Redwood app is a React server container. And what we're going to do is we're going to run the yarn Redwood dev, which is spins up a dev version of the Redwood app here that's going to run locally on my development PC here. And so while that gets started, just going to bring you through some of the React components that I've created for this particular demo. So you can see here we have the structure of the Redwood app here. I'll just show you now. It has a API. An API then deals with all the GraphQL and querying the database, and it has a web component. And the web component have these React components, and the React components, I've created quite a lot of them for this demo here, and I'll talk in detail about the endpoint now in a second. But the best thing to know about is that there is these React components, and Redwood has this concept of a cell. And a cell, what it does is it will make a GraphQL request to the backend via the API, the GraphQL API, and it will render those results using React components. So we're going to have a look at that now. So the server, development server, has almost all come up now. So we're just going to click on this link and it will open up our Firefox, and we'll have a look at the Redwood app. And just want to highlight that this React server here is running on my local host, so that's on my local development PC. And I have another Matter dashboard which is running on the Matter Cloud Controller, which is running on the Raspberry Pi. And we'll be seeing through this video how we can develop on the local development machine, push those changes to GitHub, and then those changes will be then pushed over to the Matter Cloud Controller. So what we're going to do is log in here to the React server that's running on my local host, and here you'll see the main dashboard here. We talked about this before in the first video. Now this is running on the local host, and if we look over on the Matter Cloud Controller, it's the same thing. We see the same thing. So if we see these number of devices here, so on the local host, if you look at the devices, I have one device set up at the moment. It's a Miros smart plug, and that's commissioned onto the Matter network. And if I look on the cloud controller on my devices, I have the same device here as well. So both the local development machine and the Matter Cloud Controller are seeing the same devices. Now what I'm going to do is, in this particular example, I'm going to set up a energy management app. So this is going to simulate a electric charging vehicle. So this particular app is provided by the Connected Home over IP SDK. So I've compiled that for Linux, and I've just started that on my Linux development laptop. So what I'm going to do is I'm going to try and discover this device. So I'm going to send a Matter command discover, which will then go and look over the IP network to see if there's any devices that are advertising that they're ready to commission. And you can see here that the energy management app has started advertising. So we should be able to pick that up now on our React server here that's running on the local host. And then what we're going to do is commission on network using the standard setup pin code. And this will send the message to the Matter controller, which will then start the process to commission. And we're seeing that's working with the app now. So the energy management app has got commissioned onto the network. So you can see here it's commissioned successfully, and there's lots of information you can see from the logs here. Now if we go back over to our React server running on our local host, and we just do a refresh and we look at the devices that we have, we should see this new device, and we do see it. It's test vendor, test product, and this was just set up just right now. So if we go and click into here and we see what we see. So here on endpoint 1, we've got a screen that looks like this. Now you can see here it looks a bit different to what we've seen before. It's just printing out some details about the number of clusters, and it's just doing a dump of the JSON string here, and it's using what's called the endpoint device template. But if we look, say, on the Miros switch that we have here, you can see here that endpoint 1 has got these clusters nicely laid out. So I've done that deliberately because I wanted to show you how we can customize our endpoint view, because you might want to be happy with the default way of showing the endpoints, but in this case we're simulating a electric vehicle charger, so we'd like to show how easy it is to create a endpoint view of the electric charger. So the key thing is this particular device has 2 endpoints. And we can go back over onto our project chip here, and we can look inside in the data model, and we can go and have a look at the device types that's being returned on our React server. So we look on the data model and we look in device types, and we just go down here. The first one we have the EVSE, so that's the electric vehicle charging. So we look at that, and this device type has a device type ID of 050C. So 050C. Now if you were to calculate that, okay, so it's 1292 is the device type for that. So if we go back looking at our devices here, you'll see that this is where the 1292 comes. And we also have a device type of 1296. So let's look up 1296 decimal to hex and see what we get there. So if we convert that, that is 510. So I'm just going to look up what this device number, so 0510, that is 1296. So if we look up the device number, it's actually there, the electrical sensor here. You can see it here on the where we searched it here. So what we can tell from this is that the energy management app that we're running here, when we commissioned it, it has two device types. It has the EVSE and it has the energy sensor device type. So we got those device types there. So given that we have those device types, we want to actually show our endpoint slightly different. We don't want to just show all the JSON figures. What we want to do is we want to show maybe a picture of a charging car. So how would we do that? So the thing to realize is that we use this idea of an endpoint cell, and the endpoint cell here uses this dynamic endpoint here, and the dynamic endpoint is past the device type list that we have on the that we've worked out, that we get from the Matter device controller. So this that I've highlighted here, this is the device type list. So what we're passing that into this dynamic component, and then the dynamic component then will look up which actual real component to use. So this dynamic component here will use this component map, and the component map will map the device type list to the actual component that we're going to use. So at the moment we're using this device type template, which is just a standard one which shows the, dumps out all the JSON dump. But here, if we don't have an endpoint we recognize, we use a default one. So when you look here, we use a default one here. Go into the switch, we can see this here. So you'll see here we have just printing out the JSON dump here of this one. So what we're going to do is we're going to actually make a new endpoint component just to show our particular electric charging component. So what we're going to do is we're going to use the structure here. So we're going to copy this device type template, and device type template uses a cell, and this cell, device type template cell, you'll see it here. It uses the GraphQL query back to the back end to get all the attributes, and then literally just dumps out the attributes. So that's what we're doing at the moment. But we want to change that for this demo. What we're going to do is we're going to change that, and we're going to use a component particularly for the device types that we have in this particular example, which is the device type 1292 and 1296. So again, what we do is we're going to create a new device type here. I've coded this already. I have the device type is called the endpoint device 1292 device 12926 cell, and then in the cell here again we take all the endpoints from the GraphQL query. We do a little bit of manipulating here. We just get all the attributes out from a utility class here. We just receive all the attributes, and this way we get all the attributes that are named correctly as well using this utility. And then what we do is we are going to then try to look up the actual cluster. So we're going to try to get the energy EVSE cluster. We're going to get that by cluster by code. The code is 153. And if we have a look at the cluster data model, so in the same folder here, we go back to the data model, and we go back up and we look at the data model, and we go in to look at clusters. You'll see here this is the cluster that we have that we're going to use. So it's 153 in decimal. So we go and use the utility class to try and get the cluster. When the cluster is returned, we check whether we have it. If we don't have it, we just say no cluster found. Then what we're going to do is we are going to use a React state, and the React state is going to go and save the attribute from the EVSE cluster, which is the state cluster. So we just look inside in the EVSE cluster. You can see here in this file it shows us the whole data model, and we'll just have a look for the attribute state. We'll do search for state here, and here's this is the state. Okay, so this is the first attribute here, and the state is of type state enum. So we'll just do a quick search for that. And and this gives us the values of the state. So we're going to use this state attribute, and we're going to use a React use state hook on this as well, and when that changes we're going to change the page. So what we're going to do is just save the state. We have some functions here which handles the refresh. So here we're going to have a timer. Every 2 seconds we're going to go and recall our data, and then here is where the real I guess the magic happens here. We just have some very simple a div here with a background image of a charger, and this is just going to show a car charging, and within that we have a div with a charging state here, and we're going to change the CSS class here to show a flashing light if the charging state is set to 1. So you see that now, it's very simple. We're just going to do this, and then again we're going to just print out the JSON structures. So this is very simply how we set up this React component. Now we need to go and tell the endpoint to use that one instead of the default one. So here back in the endpoint cell, we're going to change this one to be, when we have this endpoint string here, we're going to go and use the specific thing that we used here. Okay, so what we're going to do is going to save that. So we're just going to make that change here, and when we save the file, what you'll see here is that the development server will reinitialize here, and if we just go and refresh this now, this change should take hold. And then you see here now we have this image of a car, and we have a dot here, and this dot should indicate whether the car is charging or not. So if we click on it, it will start charging, but it'll go back to not charging because the state is always 0. Yeah, you can see here every 2 seconds the GraphQL query has been called again. That's checking out the thing. So every 2 seconds there's updates happening to the GraphQL server. So what we'll do is just go over to our database now. Okay, so it's going to show you what happens when we change the attribute, value of our attribute in the database. So this attribute is attribute 0. So we're going to change this to 1 to indicate a charging state of 1. We're going to save this, and when we save this now, you'll see now it looks like the car is charging. And if we go and just move this to the side, and I'll show you, if we change this back to 0, so indicate that it's not charging. So let's just go change this back to 0, and then if we change that, then the charging will stop. Okay, so you'll see that now. Okay, so that's how that works. So when we're happy with that, it seems to be all working, we can just control out of that and stop our development server. Now, the purpose of this video is to show you the continuous integration and continuous deployment. So I've just done the development part there. So the next thing I want to do is we want to push this to GitHub. So let's just look at the status. We have 2 new files that we changed, obviously our endpoint cell, and I made a small change to the sidebar just this morning as well. So what we're going to do is we're going to go and commit these files to GitHub, and then we're going to kick off a process of a GitHub action which will go and build our Docker containers. So we just added these files. So we're just going to, okay, so we're just ready to commit these files. So just put a little message here on what we're doing. We updated the endpoint. And what we're going to do is we're going to push this to our GitHub now. Okay, so I've set up the GitHub actions not to kick off after every single push. Here I'm showing you the cloud version of where I host the cloud version of the Matter dashboard, and because I pushed this information to GitHub, it's now going to be building this particular change, and this change is going to be publicly accessible on the public internet. But what I also want to do now, this is fine, this will go and deploy to the public internet. I want to change what's on the local Matter controller. You can see here, this is still the old code. So how I'm going to do this is I'm going to go and kick off a GitHub action. And I'm going to do that. Here's the GitHub action here. And we're going to do that. We're going to publish, and we do this based on a version tag. So we're going to tag it with a version, and what that will do is then it will do a build here, and it'll also do a multi-architecture build here, because we want to build for both ARM and for AMD 64. It will build the both the server and the API. We'll build the web and the API part, and then we'll push that to Docker Hub. So what I'm going to do is I'm going to go and tag it with the new version of the tag, which is version 0.0.26. And then what I'm going to do is going to push that tag to the origin. So we're going to do that, and that will kick off this Docker GitHub action. Okay, so what I'm going to do is if I go back over, you'll see this here. If I go back and I push this tag here, this new tag, that should kick off this action now. We're just going to watch that happening here now. So if I refresh this now, it should have started a new workflow run, and it has started that now. So this is going to kick off and start to do the Docker publish. So what we're going to do is we're going to go and set up all of the Docker build X. We're going to log into Docker Hub using the credentials that are stored in the GitHub secrets. We're going to start building the web and the API, and building the web API will then also push this to Docker Hub as well. So this takes some time. This could take maybe half an hour or so to go and do. It's quite a lengthy process to do that. But what we'll do is we'll come back when this is all done, and I'll show you what it's like, or how the images have been pushed. So over on Docker Hub here, you can see the repositories that I have. And I already have these three GitHub, I already have these three Docker repositories, and what's going to happen is this corresponds to these images that are built and pushed. Okay, so when this GitHub action works, it's going to go and push it to the Docker Hub repository. Now over on Netlify, that build has finished. So when I actually log in using the publicly accessible website here, and I go on here and I go to devices, now I should see my new device here, and if I show my new device, I should see the changes that I made. So hopefully you'll see this now, and like that you can see the changes that I've made here. So those changes have come through onto the publicly accessible cloud version of the React server, but they're not accessible there on the local one. Okay, so the Docker build has finished. So the Docker build is finished. So what happens here now is that if you see here, the repositories now have been updated, and here they've been updated just a few minutes ago. Okay, so all of these new images have been pushed there. Okay, so the Matter server has been rebooted, and here we can see when we go into the devices, and now we can see here on our Matter Cloud Control local, so on our Raspberry Pi, we actually have the new version of our page there. So it's easy as just that. So basically what happened in the background is that the Docker containers were updated, and then when we rebooted the Matter Cloud Controller, what that did is it part of the reboot script, it actually pulled in the latest version of those Docker containers. So you can see this is how it took in this information. Now what we're going to do here now is we're going to show that if we actually change the actually plug in a so we actually go into the endpoint here, and now that we have this working, what we're going to do is actually simulate actually plugging in a real life charger.